Welcome back, everybody. For this section, we cover Earth's interior. So our very first question here, how did the Earth get its layers? And the sort of thought experiment for this one is the glass jar Earth. So you have a glass jar and you put rocks and soil and water and air and all this stuff in there. Putting air in there is pretty easy. And you shake it up really, really hard and you wait. And what happens? Well, the heavier stuff, the rocks, start to sink to the bottom, and then you would have these different soil-y layers in between, right? The medium density stuff. And you would have the light stuff, and then the water, and then the air at the very top. And this is the same process that the Earth went through whenever its different layers were forming. It's a process known as differentiation. So differentiation is our process which takes this magmatic Earth, really, really hot, molten lava everywhere, and starts to slowly bring out the patterns in the interior. Really, really dense stuff sinks down to the core. Lighter stuff forms the crust. So this is the outermost layer. This is where we live. It's sort of the thin, rocky skin of the Earth, this residue scum. We have the mantle in the middle, much thicker than the crust is, thicker actually than any of the other individual layers. It is also rocky. It's going to be denser than the crust. It's really, really dark rock, mostly solid, like 99% solid, but partially molten. It's just molten enough to where the rocks can kind of move around like a liquid sometimes. Well, we'll get to that later. We have our outer core and our inner core. Outer core is high density. It's going to be liquid iron for the most part, responsible for Earth's magnetic field. Might remember that one. And the inner core, which actually is under so much pressure that it is solid iron-nickel alloy sort of material. And before we get too far, I should mention, other planets in the solar system exhibit differentiation as well. They're divided into layers the same way that the Earth is. Now, going into a little bit more detail, because I'm sure past material was stuff you've all heard before, there are sort of two ways of breaking the Earth into layers. You can either do it with composition, right, like chemical composition, what the material is made out of in terms of the different elements. That's where we get crust, mantle, core, like that. The other way to do this is based on rheology, so rheological zonation, how the different materials flow. In which case, instead of, crust and mantle, you split it into lithosphere and asthenosphere. And the lithosphere contains the crust and the uppermost solid part of the mantle. But the difference is the lithosphere acts like solid rock and the asthenosphere acts like more plasticky, partially molten rock, able to mold and move around almost like a liquid. And it's worth noting, once we get to plate tectonics, actually the plates themselves are not crust. They are made out of lithosphere. The plate contains not just the crust there, but also some of the upper part of the mantle, much thicker. Stick around for the next section. We're talking about Earth's systems. See you then.